So can we quickly summarize what we have discussed in our last session? Any one of you guys? What have we talked about in our last class, guys? Just one or two lines, probably.
Static value variable, and how to use that one. You can change a value when and when not. That's what we saw. And it's kind of final value. So we call that method and we use as a parameterize, and then when we call the method and static value, once the static value is not going to be changed in the next parameter, but it's changing the method what we use for that. Yeah, that's what I'm doing.
Okay. Okay. Let me just add here. So in our last class, we started by discussing the call by value and call by reference concepts. So which is basically how the arguments are passed to a subroutine method, right? From in Java. So we talked about Java is call by value by default. Like if we took the example of some of the primitives and primitive types like integer, we took one example and we saw how it is working, right? So there we are passing the copy of the variables. So there it's by default call by value. But when it comes to objects, when you pass object as an argument to one of your subroutines or method, there we are actually passing memory address of that particular object. So end of the day, you're modifying the same object, right? So there it is called call by reference. Okay, that's one key thing we try to understand. And then we spoke about recursion. What is recursion, how it works recursion? So in that we just simply talk that it's a process in which a method is called itself. So on the right slide, whatever you are seeing, right, that is a recursion. So we just understood the difference between a normal method call and a recursive method call, right? Like suppose there is a method like math, and in the same inside the method, if we are calling the math method again, that is a recursion, right? And if you're calling from outside class or outside method altogether, then it's a normal method call. So we just try to understand the difference between understand exactly what recursion is, right? And I did ask you guys to implement the factorial program, whatever we have discussed earlier in recursion. I hope you guys have done it. We'll just about to see that now. Okay. And then we spoke about, we introduced two new keywords, which are static and final. And we try to understand differences between them, right? Like static is a keyword where if you have hundreds of objects of a particular class, all of the objects will have a same, only one copy of that particular variable or method, whatever you make static, right? You can make both method and a variable as a static. And when you put a static, you give it some default value, and then you can initialize at any point of time. You can reassign some other value to that static variable, and it would reflect across all the objects, not just in that particular object, right? So just keep in that mind, because your static variable memory is created at once for all the any number of objects whatever you may have, right? So your static is always a one copy of that particular variable. So if you change it, it would reflect across all the 100 things, 100 variables, right? All the 100 objects that we have. So basically we can reinitialize. And then we talked about other keyword final, which is basically once you made a particular variable final, then that value will be same. right? Throughout the life cycle of that particular object. You can't change the value. Like, for example, you get initially assigned to 10, right? You cannot even change it to any other, right? By default, when you create that variable, you have to initialize it with some value. The same, the key difference between final and static is static can be reinitialized. Like you initially gave it some value, at any point of time you can change it, but final, that is not the case. Once you give it some value, that's it, it's final, it can't be changed, right? So normally in programming world, right, use uh, the best way we use constant. Like if you have a certain variable and you want to call it as a constant, that means you don't want its value to be changed ever in life cycle of your application, right? So in that case, we would tend to normally name that variable as a static final variable, right? So that it will remain as a constant. So like, say for example, you want to create a constant variable here, right? So you will just simply name it as a static final. So all static final variables in Java are constants. Okay, static final, and whenever you put constants in Java, you should probably mark them with a capital letters, all the name. Okay, so let's take what can be our, so suppose author. We took author name. Okay, I also need to mention the type, right? String. Type of my variable. I took a string variable, for example. Author. What happened? You can create a static constant variable like this. This author is the name of the variable, and string is the type, right? Type of this variable. It can be integer type, it can be character type, or and static final. Even though you create 100 objects of this test2 class, you will find the same value of this author, Sriram, everywhere, whatever we were declaring. Okay. Yeah. So now, any questions, guys, on what we have discussed in our last session? So that if there are nothing, we'll move on to today's session. But before that, how many of you guys tried recursion of the factorial program, whatever we discussed earlier? You all guys have done factorial using loops. So any one of you implemented using recursion? Okay, forget about successfully implementing it. But any one of you just give it a try to implement it and implement it. Okay, guys, take one more day. Tomorrow, I want some answers for it, right? Recursion, where we will implement a factorial of a program using recursion, right? Okay. So today we will talk about, so far we were all this couple of days we were talking about classes, right? So we'll talk about the two classes, string class and object class, which are part of Java ecosystem. Okay. So let's talk on a very high level of them, right? And we'll move on to the inheritance concepts today. So basically, let's start with string class, right? So what is a string class? And this is a most commonly used m- class in Java's class library. So typically a Java programming language, if you take, right, it comes with so many predefined classes which are built already for us to make use of certain features, right? So string class is a string class is very important actually, right? Because whatever we deal, right, we normally deal with some text based values most of the times, right? So basically we string is a class, right? So that means we can basically create an object which is of type string, right? And if we take about, so far we have written statements like system.out.println and all, right? So this print is what they all this part. So basically your system.out.println, it is not, it returns a string, right? But system.out.println basically tells you to basically print it to the console, right? And normally if you want to create strings of ourselves, we would do something like this, what we just did here, right? String or that. So probably I'll just put it, I'll just give it a bit more simpler touch. Like probably we can take here string other, right? You can just create a string here and assign it some value. Other equal to hello. So you can assign it using the string literals. This is called string literals like this, or you can use new operator. Okay, you can say new of string like this. Both are valid ways. Okay, you can create a string like this using new operator, or just assigning it, right? So if I just click on this class string, if you see, right, string dot class, and if you see, this is the public class string, but it has some final keyword. We'll just try to understand. This is a class which is built by your Java library, your Java source code. It's part of, it's already pre-built class. And if you see, it's a very big class, right? There are somewhere around 3000 lines of code in this particular class, right? So like I was saying, right, this contains a lot of predefined variables, like for predefined methods to manipulate your strings, right? So for example, if you take other and you use dot operator and look at the hints you got. It has caret method, quote point, concat, contains, right? Ends with hash code equals. I mean, hash code equals, they are part of object class. We will discuss that. And if you see length, right? Let's take length. So length of string other, right? So it will just print the length. So here length is basically 1, 2, 3, 4, 5, right? So it will just print the length. You see, length of string is 5. String order is 5, right? So likewise, you have some more methods like if not length. You have another method like for example, let's see more. Okay. Value of is used to, we use value of method. Suppose if you have an integer value, right, and if you want to convert into string, then we use value of. Okay, so we have a lot of method like this. For example, lowercase, we'll convert everything in lower. For example, to uppercase, we'll convert all these letters into capital letters. Okay, we'll just see. See here, hello is converted into two uppercase caps, capital, right? So likewise, Likewise, we have a different methods in strings, lot of methods, right? Like say, for example, you have the char at method, like say, for example, and how the strings are stored in the backend, they are used in form of a character arrays. Okay, so if you use this char at method, okay, for example, I'm just using that method now. The char at method, it takes an index, so that means it starts at 0, 1, 2, 3, 4, right? So if I put the element at index, what should be the output here? Char at 1. What should be the output, guys?
E.
E.
E, right? So on the back end, it is stored in a form of a character array. So you have methods like caret, and you also have methods like substring. For example, yes, substring. You have a just index based, or you also have a begin index and end index. So if you see this, if you try to fetch elements from 1 to 3, right? Basically 0, 1, 3. It will print here. It will try to fetch the part of the string. So which is 1 will start with here, right? 2, 3. So this would print ELL. Okay. It starts with, okay, it printed EL 0, 1, 2, 3. 4. Okay, I think it's taking -1 character. Okay, so substring will fetch the part of that string. Okay, so like this, within string class you have so many methods, and if we talk in detail about string, that itself is a lot of things to be discussed. Okay, so but from interview perspective, couple of things I want to discuss about string class. Okay, first of all, I want you guys to explore this string class, right? Like just explore each and every method. So take a string, take a sample string like this, and put a dot and see all these methods, whatever that are present inside the string. I want you to explore all these methods. Okay, so go and explore this. And one thing you guys need to understand from interview perspective are, so the first question normally you will see in a lot of interviews, right? So see, so far interviews will ask you theoretical questions, right? What is this, what is that, and all, right? But in some interviews they'll ask you to write program. Okay, they'll ask you to write sample program. Like for example, they may ask you to write the factorial using recursion. They may ask you that, right? So but normally in most of the interviews, people tend to ask interview questions with respect to strings, right? Say for example, so normally they'll give you a string like hello, HELLO, right? So they will ask you to write a program to reverse that. You guys understood, right? This is a very frequently asked in many interviews. Okay, they'll ask you, can you write a program to reverse my given string? So if I reverse this hello, what would be the output? OLLEH, right? If I reverse it, yes or no? Are you
Yes.
guys following me? Yeah. So they'll ask you to write a program for this, okay? And if you see, string directly provides you some implementation with reverse, okay? Like say for example, you have a reverse method in string. Okay, reverse is there in the string buffer class. Yeah. Okay. So they'll ask you to write this program to reverse the string. Okay. Normally, string have two more specialized classes called string buffer and string builder. Okay. So in that, you have a reverse method. You just call reverse method and it would uh, like I was telling, right? Okay, let's create this classes. String also has two new specialized classes like string buffer str equal to new string buffer str equal to new string buffer. This is another class that is available within Java library. Okay. I was saying, right? Java builds you so many default classes. So this is another such class. If you take here and if you give hello, right? This has reverse method. You have a reverse method, right? So if you see the output here, output is the reverse of it, right? 𝐿𝐿𝐻. So they'll ask you to implement this particular code here, code of reverse, right? So if you see string buffer class, this is the string buffer class. It is part of which package? Java.lang, right? So this like I said, right, this is built by the Java developers for us. Java, who developed the Java in first place, they written a lot of default classes for us so that certain operations which which are needed by many people, right, they made it easy. And if you see the a reverse implementation, you will have some implementation for reverse also here, right? Here you have a reverse and it's calling super.reverse. So that means there is some specialized class which is basically containing the super. So it contains it implements the char sequence and comparable couple of things, right? So probably in char sequence or somewhere, or probably extracts abstract string builder. Probably here you may have a reverse implementation, right? Reverse. Yeah, here if you see, you have the reverse implementation, right? Code. So here they are actually reversing the string. This is the code. Okay. So this is how we can reverse a string, right? So this is one such program. Like you get so many default implementation. And similarly for substring also, for character also, to uppercase also, there are different implementations which are basically provided by Java for us by default, right? Here if you see again, there is two uppercase, some static here, right? So there are some utility classes, and using that they are converting this to uppercase values. Okay, so like this, the string classes are very vast. Okay, so but you have string class. Why do we need string buffer? Okay, in addition to string buffer, you also have another class called string builder. Okay, builder, builder. Okay, so this is also another class, right? So now I am talking the next important thing in strings. Okay, so the key thing is one thing we need to understand, right? In Java, whatever objects we create string are immutable, right? Immutable in the sense, what is immutability, right? Say for example, here we created an author object, right? And what is the value of author? What is the value of author, guys? So
Hello.
this is our Java memory, right? And here we created an author variable. Okay. So author will be on stack as usual, which we know. Okay. Here you will have author. Okay. And what is the value of author here? Hello, right? So in heap, you will have this value stored, hello. This is our string, right? And you know this is how it maintains the link, right? Now, like I said, right, strings in Java are called immutable. Immutable means that cannot be modified. Mutable means which can be modified. Okay, so so as I was telling, right, we were talking about strings, and I said strings are immutable. So basically, what is immutable? Like I said, immutability is nothing but it cannot be changed, right? So that means, let's take this example. Here we have author hello. This particular line, it creates the strings in memory this way. Okay. Now, if I try to change the value of author like this, I'll say author. It's a variable end of the day, right? You can reassign it. I'll change it to high. What will happen, guys? What will happen in the memory?
It will change it to high.
Yeah. It will change it to high. This is what we know, right? Yes or no?
Yes.
It will change it to. Okay. Yeah, it would change it to high. This hello would be overwritten, right? So this is what will happen. This is how it will happen in Java as per our understanding currently, right? But in case of strings, this will not happen this way. Okay, it will create another object like this, another string like this separately. Okay, and it will change it to high here. This is again a string class, right? And it will erase this particular link, right? It will create a new link like this here. Okay, so this is how Java strings will work will get stored in the memory. This will happen only with respect to strings, because strings are implemented in a immutable way. That means once you create it in memory, you cannot modify it. As simple as that. You guys are understanding me, right? Once you create a string in memory, it is immutable. That means it cannot be modified. When you create new strings, when you assign something, it will create a new object altogether, and it will update the reference to that particular memory location. Okay, so that's why when you use strings in Java, you have to be really careful. Else, if you try to reassign that string multiple times, right, then you will have so many unwanted strings in memory, and eventually it would lead up to what? It will create so many unnecessary strings, because every time you try to modify it, it will not override the existing. That was the case with respect to the objects or whatever we saw so far. The other type variables like integer or whatever there that are stored in memory, if you reassign it, it will get overwritten. It will not create a new because they are mutable, but your string class is immutable. So it will create a new. So what will happen if you try to create if you try to change a string too many times and all, what will happen?
We ran out of memory.
Yes, we will run out of memory. Okay. So if there is a slightest chance where new Java programmers may end up writing a code which will eventually lead into out of memory exception, right? So normally in my experience, I saw so many beginners don't use strings properly in their programming. Okay. Because of that, there will be big, because of string resulting into out of memory exception. It's a common practice that normally we see across so many beginners of Java programming, right? So you have to be like really careful when you use strings within your Java program. Okay, you try to explore the best approaches and then give it a try. Write your code. Okay, so to have an alternative of string class, right? String class is obviously mutable. To make you, if you want a mutable string, right? Then Java provided you these two classes, string buffer and string builder. Okay. So one of them is a thread safe class and another one is not thread safe. String buffer is thread safe and string builder is not thread safe class. Okay. So like what is thread safety and all, we'll understand at later point. So just remember it for now. Okay. So the string buffer and string builder, they are mutable classes, right? So if you take string buffer like this, it's hello, right? And if you again change this str to hi, right? If you change this, it is not going to create a new object. Okay. It will just override the same. Okay. It will just overwrite it. But in case of string class, it will always create a new object. So just keep that in mind. Okay, strings in Java are immutable. As simple as that, just a single line of statement. I mean, it's really famous in interviews. They'll ask you in the same way. Like they'll say other equal to hello, other equal to hi. What will happen? They'll ask you like you have to tell strings in a Java are immutable. So every time you try to reassign it, it will try to create a new object always. It will not override the existing memory that has been created for the previous value. Okay, just keep that in mind. Yeah, and clear with the string class. Any questions?
What's the purpose of string builder?
Both string builder and string buffer are just to have a mutable versions of that string class. Whatever drawback string class has, to have a mutable version, we have string buffer and string builder. But if you ask me difference between string buffer and string builder, which I said, right? String buffer is a thread safe class. String builder doesn't have any thread safety. What is thread safety and all, we will discuss when we talk about multi-threading concept. Okay, for now, just remember it. Okay. Wait, I'm a bit confused. Which of the class is string safe and thread safe and let me just check. So you just go to Google and type differences between string buffer versus string builder. Okay. One of them is a thread safe class. Okay. String buffer is a thread safe. I think what I said is correct. Okay. String buffer is a thread safe class. Okay. And string builder is a not thread safe. What is thread safe and not thread safe, we will discuss at a later point. Okay, but end of the day, both serve same purpose. They're there to provide you with manipulations of your strings so that they'll make your strings mutable, as simple as that. Okay, any other queries? For now, just remember the difference between string buffer and string builder is thread safety. Okay, I'll explain you at a in our later session what is thread safety. Any queries here, guys? Okay. Now we're going to talk about our next class, which is object class. Okay. So basis what is object class? Okay. So like how you have string class in Java, we also has object class. Right. Say for example, object itself is the name of a class. Okay. 𝐵𝑗𝑒𝑐𝑡. Object. Yeah. So Java by default provides you this object class. This is the object class. Okay. And if you take this OJ and just put dot, you have some methods here, right? Which by default your object class provides. What are those methods? What are those methods, guys?
It's equal get
Class,
make
yeah,
Hash code, notify,
modify load to string.
Wait, right?
Mhm.
So you have certain methods within object class. Yes or no? Like every class, object has also certain methods. Like I want you guys to explore in detail what each method is. Okay, this is an exercise for you from this class. Okay, but what I want to explain, right? Now let's take string class. Okay, this is yes, this is the string class, right? So I'll say other and dot. We discussed there are a lot of methods, right? String provides you this length to uppercase character method. But if you put dot and see, it has equals method. And if you scroll further, it has hash code method. It has notify all. And in it has wait method. So that means if you look at the object class again, all these methods are part of this particular other, which is part of string class also. Yes or no? Can we say that? All these methods, they are part of the string class also. If you see here, you have a equals method, right? Here, other has equals method. This string class basically has equals method, right? Equals object. And if you see object, it also has equals method. Yes or no? So basically, all the methods of your object class are part of your string class. And similarly, we created our own custom object here, right? Which is test2, right? Test2 is a one of, or probably let's take this test. Test is a custom class which we created, right? Yes or no? Now I'll take this test object tj and I'll try to do tj dot. How many methods are there in my test class, guys? This is a custom class which we created as a programmer. How many methods are there?
one,
One method. What is the name of that method?
math,
Math. Okay. So when I put dot, I should only get math method, right? But if you see, okay, I got math method, which we created, but I am also getting these additional methods. Equals, hash code, notify all, to string wait methods. Wait, you have 3 different versions. Okay, 3 overloaded methods are there. Wait. Are these methods present in test class? No. They are not present in test class. Test class only have one method, right? Which is math method. But why are we getting these many methods in our test class? Right? If you observe, all these equals, hash code, notify all, to string wait method, originally they belong to which class? They belong to your object class, not string, object class. Okay, but string class also has these methods. Okay, if you observe, your object class, if you go to your object class, right, see here you have all these methods. You have get hash code method, okay, and you have a equals method, right? You have a toString method. You have a notify method, notify all. Guys, whoever is not speaking, please go on mute. And you have wait method. Right? Guys, whoever is not speaking, please go on mute. Yeah, thank you. So if you see your these methods, get class equals notify hash code wait, all these belong to your object class, but at the same time you can access these methods in string class, which is the inbuilt class of Java, string class. And also at the same time we can access them in our test class, which as a programmers we created ourselves in one of our last classes, right? So that means can we say that whatever methods in object class can be accessible to all the classes that we create in Java? Can we say that?
Yes.
Yes, right? So that's what, right? So whatever method that is part of object class, it will be accessible across all the classes, both the inbuilt Java classes and at the same time custom Java classes, whatever as a programmers we create, right? These methods will be accessible across all these classes. So that means can we by this we can say object class is a super class of all the classes, right? Or whatever class you create in Java, the super class of that class is, or parent class of that class is what? Object class. Okay, that's it. Just keep this in mind. I want you to go to object method and explore object class and explore this method. This is an exercise for you. Just some research assignment you can think of. I want you guys to explore both within string class and object class. Explore all these methods. Okay. Some you may understand at this moment. Some you may not understand. Like for example, notify and wait. You may not understand because these come in a multi-threading concepts. These things will come when we talk about thread concepts. Okay, but others, I think you should be able to understand them. Yeah. So I think with that we concluded the classes. Okay. So next thing we are going to talk is inheritance. Any questions, guys, on the object class, whatever I just said?
So I have one question. So how often would they ask us to like perform a code, write a code without a method?
Write a code without a method. I
I mean,
didn't understand.
how often would they ask us to write a code without using a method? Like, can we normally use just a method, or like would they ask specifically to not use method and then just use some other way?
That is just some logical segregation, right? You put it or you don't put it, it doesn't matter. Okay. Like for example,
like reverse hello, we can do it in so many ways, but using a method, it's easy. So would they ask us like not to use reverse and
they will tell you, right? If you when I asked you to write a program for reverse, if you just simply do this, right, then how would I know your programming skill? How would I know you can? So for me, I would know your programming skill if you actually write the implementation. If you write this code, then I'll say, right? Then I'll think as you as a programmer. If you see here, how this code is implemented, just using one for loop and if loop. Very simple, right?
Right.
So I would expect you to write this code rather than this. If you write this code, I would think yourself as a programmer. Reverse, it's straightforward, right? Like you just put reverse. It's just that all you need to know, you would use reverse. But in real time, in real Java, if at all in your day-to-day programming as a developer, if you have to reverse string, you will obviously use this reverse function. You will not write this whole code because we should try to put minimum efforts. We would always try to make use of something that is already available in Java, right? Normally in day-to-day application, right? You're developing something and you have to reverse a string. You would just directly call this method. You will not write this code from scratch again. But like I said, in interviews, they may ask you to test your programming, right? Like whether you are faking it, or you are real, or probably to understand that, probably to understand how good of a programmer you are, right? So they'll just try to think in all these aspects, and probably they'll just try to understand your thought process as a programmer, and will just try to ask you these questions. Okay, understood, right? If at all, when I ask you reverse, if you're not able to move an inch, then they may not think that, okay, you don't have enough experience as a programmer, right? But at least if you write some code, or if you give a thought process correctly, like pseudo code, if you tell, okay, this is what I'll do, this is how I'll do, then they'll think, okay, fine. Okay, fine. They know something, right? So like they kind of sense that, right? Or if you write complete code, then it will be really good. Like you will get a good score there, right? Sort of. Yeah. At end of the day, it purely depends on the discretion and whatever they are specifically looking for in that particular candidate, right? So it goes like that. Yeah. Understood?
Yes, got it.
Okay. That's why, right? It's really important you execute the earlier basic programs that I gave, right? Be it factorial or prime number. These are like just a basics, right? The reverse, you can implement using if and for loop. You just need to think. This is the reverse of a digit we implemented here, right? If you see reverse of a number 456 I gave, the output should be 654. Here ours is a string, so obviously we can't divide it by 10, multiply it with 10, and add it with 10, right? Can we do that with a string? No, right? So just think of an approach and come up with a solution. Okay, you can take this as assignment. There are hundreds of solutions on internet. Okay, first you give it a try, and then try to look at the internet, and that's how you learn things. That's how you build skill. Okay. Okay, having said that, I was telling about object class, right? Which is a superclass of parent class of all the objects that we create in Java. So any questions, guys, on this, or else can we move on to our next topic? Okay. And the next concept we are talking about today is inheritance, right? So inheritance, I think if you remember, inheritance is one of the object-oriented principles, right? What are the object-oriented principles, guys? Can one of you name it? Name them.
Abstraction, encapsulation, inheritance, and polymorphism.
Right. Anything else is there, or just that?
Class and object also.
Okay. Right. So inheritance is one of our basically cornerstone of our object-oriented programming. So because of inheritance, we can compose our classes in a hierarchical structure. Hierarchical structure in the sense like a tree structure, like this hierarchical structure. This is a hierarchical structure. These are hierarchical structures, right? And using inheritance, we can create, suppose you have 10 classes, for example, in your application, and all the 10 classes have one common behavior, common method. So in that case, we can create a common traits of a set of related classes. You can create one class, and you can move this common method to that particular class, right? And you can make that class as a superclass to all the other classes. And other classes are called subclasses, which can basically reuse the behavior of your superclass. So basically, inheritance is a concept that basically helps you to compose or design a classes in form of a hierarchical, like a tree structure. Like you have a tree from a single branch, there will be multiple branches arising out, sort of, right? So something similar analogy you can make out of it, right? and it basically depicts a is a relationship kind of thing. Is a, what is a? We'll look at it, right? And in general, in Java, right, we implement inheritance using extends keyword. Okay, extends, EXTENDS, extends keyword. And in Java you have a multiple types of inheritance: single inheritance, multi-level inheritance, multiple inheritance, hierarchical inheritance, hybrid inheritance, and all, right? But multiple, it's not possible in with respect to classes, but inheritance it is. We will look at that. It's a bit tricky, but if you ignore multiple inheritance, the main types of inheritance we normally tend to use are single, multi-level, and hierarchical inheritances. We use them quite a lot. Okay, so why, first of all, why we need to design our classes into a hierarchical structures like this, right? Like I said, to remove the common behavior and make it as a common across all the classes that we have, right? So basically what that imparts to your application, what that will impact to your application, guys, if you try to remove the common code across all the 100 objects you have and you put it into one particular object, and you just make use of that object in all the other 100 objects so that you can reuse that functionality, sort of, right? Yes or no? That's what we are trying to do here, isn't it? So that means inheritance helps us to achieve code reusability, right? So that's what inheritance is all about, and it is one of the cornerstone of your object-oriented programming principles. It's frequently used. It's used quite a lot of times. And like I said, we use a keyword called extends. Using extends keyword, we implement inheritance. And as I was saying, you have different types of inheritance: multi-level, single, hierarchical, hybrid, multiple inheritance, like different combinations. Okay, so let's just see some basic example of single inheritance. Let's just start with single inheritance, and then we'll talk about it, right? Like when I talk about is a relationship, what exactly is that? Let's just check that now. Okay, you have a class here. Okay, let's call this as class A. Okay, and then you have another class. Let's call it as class B. Okay, I'm just giving you some analogy here. Suppose let's assume class A has some method like math method. Okay, and here in class D you have some method like multiply. Okay, now I can create a class E. Okay, you have another class E like this, right? But if I want to create a hierarchical relationship between class A and class E, for example, right? So I'll make a class A as a super class, and I'll make my class E as a subclass. Okay, so now you have two terms here. This is a subclass, and this is also called as what? Parent class. PARENT, parent class. And let's assume this class E is a subclass, HUB sub, or child class, parent child super sub. Understand this terminology. Okay, when I want to define this sort of relationship, then my class E would be actually created here inside this. Okay, so inside here you will have, I mean, it's not in memory, it will not be created that way. I'm just giving you an analogy of that. is a relationship. Your inheritance defines a is a relationship between classes. Okay. So now if you see here, this is how your class E will contain. That means here can we say class E is a child of class A, right? Class A is a parent of class E. You are understanding these two differences, two statements that I'm making, right? Class A is a parent of class E, right? And or else I can say class E is a child of class A, right? Both these statements are true, yes or no?
Yes.
So, but what is the advantage of this? Why we should have this kind of a relationship between easy relationship between two classes like this? Why we should design our classes this way? Because what our math function that is available in class A, it can be automatically used in class E. So thereby we are reusing the code, yes or no? You got my point? What I'm just trying to tell you guys. So whatever properties, methods or variables that are present in class A, they can be automatically accessed in class E. That means just by defining an easy relationship, even though our class E is empty, for example, it doesn't have anything new. Okay, but it can also have its own new methods also. It can have its own methods also. But at the same time, by creating an inheritance between the class A and class E, your class E can also reuse your class A methods, right? So that means this math can be a common functionality to many classes, right? So that's why we are defining this is a relationship between your two classes. Okay. Let's just implement this programmatically, and then probably that things would make a bit clear to you. Okay. So I'm creating a class A here. Okay. That's it, done. And inside my A, I'll create two variables out. Okay. Let's create some two variables. Like for example, integer. I'll create one variable, integer A. Okay. And I'll create one method. Okay. I'll create like void show method, show A. This out print A. Okay. This is a simple class which we know, right? Which we understand this format. Yes or no? So this is creating this outer class. Instead of math method, I created a show method here, as simple as that. Now I'm going to create another class. First of all, to create that inheritance, you need two classes, right? Class E I'm creating. Okay. So now let's assume our class E also has another method. Like for example, we'll take just copying this A, and let's assume it has another variable like C, and I'm saying print C, show C, right? So now if you see here, this is how our both classes are. Okay. This is our class A, and this is they are completely isolated class. They don't have any relation at this moment. Okay, class E, and this has show A method, and this has show E method, show C method. Right? This is what we have done. If at all, if see now, if you want to create a relationship of E between these two classes, that means class A is a parent of class E, class E is a child of class A. If you want to create that kind of relationship, What is the keyword we use? I just said some time back, right? What is the keyword we use to implement inheritance in Java?
Extends.
Extends, right? So how do we use that keyword is, I will come to my class E, child class, and I'll say extends. And I will put class A name. Okay. So I'll just put the N here, extends. That's it, done. Now if you see, I created this kind of a relationship now. Okay, this is my class A, this is my class. Okay, this is my class E. So I created that is a relationship. Now if you see, my class E is a child of class A. But what is the advantage of this? Right? We'll just see that now. Inheritance demo. Insert state main method. Now I create an object of class E. Okay. E equal to new of E. This you already know, right? We just created a new object of our class E. Now let's assume this is not there. I'm just putting E dot. You can only access E dot C, right? I'll give it some value like 5. And you can access this show C method also, C and show C. See, we can access E dot show C. Okay. What would be the output if I execute this? What will be the output, guys? What will be the output? Just close this. Okay, so now what will be the output if I execute this?
5.
We will just give this print C 5, right? Very simple output, nothing much. Now, using my object E, right? Can I access anything in A? Can I access this variable A or show A method? Can I access, if you see, is it available? They are not available, right? But now, let me use this extends keywords. Now see the magic. Okay. Now I can access A value here. And at the same time, I can also access this show A method, which is present in the class A. You see here, show A method. Right. Now if you see, you will print C value, print A value. Print A is present in class A, print C is present in class E. All this I did using only class E object. So we know that using one class object, we cannot access other class methods. But here, using class E object, we were able to access class A objects because of what? Because of the inheritance. Because your class A, your class E is extending class A, right? Your class E is a child of class A, right? But if you see E dot here, yeah. But if you see E dot here, sorry, yeah. You see E dot here, I can also access this hash code notify all on this. Why I am seeing these methods? Get class hash code notify all wait 2 string. Why I'm seeing these methods? Why I'm seeing these methods, guys?
The inbuilt method.
They are part of the object class. And what I just said some time ago,
So object is a main class.
object class is the super class of
Every class.
every class, right? So that's why if you see whatever methods you're present in object class, you can access at object E class. You can also access them at class A also. Even here also you can access them. In class A also you can access them. In class E also you can access them, right? So that's why but here that relationship object class is superclass of every class is by default created by Java for us. But if you see this relationship in classes A and E, this kind of parent and child relationship, this we created ourselves, right? This is not something created by Java for us. Understood, right? Understood, right? Object class relationship is by default available for us. We haven't created that. Any questions, guys? We'll stop here. So today we just spoke about single inheritance. Okay. Tomorrow we are going to cover about other types of inheritance. We'll talk about abstract classes interface, the much more advanced concepts in Java. Okay. We'll stop here. I'll take any questions for a couple of minutes if you have. Any questions?